Today we will discuss about logic microoperations. Logic microoperations specify binary operations for string of bits stored in registers. These operations consider each bit of the register separately and treat them as binary variables. Suppose we want to perform exclusive OR microoperation with the content of two registers R1 and R2 that will be symbolized by the statement R1 R1 XOR R2. It specifies a logic microoperation to be executed on the individual bits of the registers. That means let the content of R1 be 1010 and the content of R2 is 1100. The exclusive OR microoperation between the content of register R1 and R2, and after that the resultant will be stored in register R1. So the content of the register R1 will be 0110. The content of R1 after the execution of the microoperation is equal to the bit by bit exclusive OR operation on pair of bits in R2 and the previous values of R1. The logic microoperations are seldom used in scientific computations, but they are very useful for bit manipulation of binary data. Remember that the logic microoperation will be used for bit manipulations of binary data. Manipulation of binary data. So, some special symbol will be adopted for the logical microoperation or and complement to distinguish them from the corresponding symbols used for Boolean expression. So, here the symbol OR, this will be used to denote OR microoperation. This will help to denote the OR microoperation. Similarly, these will denote the AND microoperation. The complement microoperation is the same as one's complement. Okay, so it will be represented as the bar on top of the symbol. Suppose we want to do the this is the complement operation. This is complement of B. Okay, so there are 16 different logic microoperations, 16 different logic operations that can be performed with two binary variables. So here they can be determined from the truth tables given in this slide. So here the 16 columns F0 to F15 represent a truth table of one possible Boolean function. Here, if we consider the case for F0 to F15, they represent the possible Boolean function. These are the possible Boolean function for the two variables x and y. Here the variables are x and y. These two are the variables x and y. Okay, and from F0 to F15, these are the 16 different functions. The 16 Boolean functions of two variables x and y are expressed with the form of the algebraic form of this table. So here, if we write f0 equal to 0, this is the Boolean function and the micro operation is clear. Similarly, f1 equal to xy, the Boolean micro operation is AND micro operation. So if we consider that the number are stored in the two registers, or the binary content is true, are stored in the two register A and B, each bit of the register is treated as binary variable. So if we consider the binary content of two register A and B, then each bit of the register will be treated as binary variable and the micro operation is performed on the string of bits stored in the register. Okay, so the 16 logic micro operation are derived from these functions by replacing the variable x by the binary content of register A and the variable y by the binary content of register B. So if we consider that the binary content of register A is 1, 0, 1, 0. And what is the operation if we want to perform F3? F3 equal to X. That means here the logical operation is a transfer A operation. That means the content will be just transferred. So the this is the content of A that will be transferred to F. Okay. So similarly, A exclusive for B. So the content A register will and the content of B register, among these two, there will be bit by bit exclusive OR operation. So when we will do the different micro operations, basically we are doing the bit by bit operations between this the binary content of the two register. Okay, so we can represent these logical micro operations by the help of some hardware. So the hardware implementation of the logic micro operation requires that logic gates to be inserted for each bit or pair of bits in the register to perform the required logic function. So, although there are 16 different micro operations, most computers use only 4 and or exclusive or and the complement because all the others can be derived from them. So, if we show this logic circuit design, here the stage of a circuit that generate the 4 basic logic micro operation is shown. So it consists of 4 gates and a multiplexer. Each of the 4 logic operations is generated through a gate that performs the required logic. The output of the gates are applied to the data inputs of the multiplexer. The two selection line S1 and S2 will be chosen to select the data inputs of the multiplexer and direct its value to the output. So here in this diagram it is 4:1 multiplexer. So there are two select line S1 and S0 where S1 is the MSB and S0 is the LSB. So 4 logic operations can be performed with the help of this IC. So here 4 logic operation. What are the 4 logic operation? The operations is AND, OR, exclusive OR and the complement. So to implement this in the circuit, we need 4 logic gate. One is the AND, another is OR, then XOR and then NOT gate. So here, if we do the AND operation, the input will go to the D0 and we will get the output as G when the select line is 0, 0. Then D0 will be selected. When the select line is 0, 1, then D1 will be selected. So when D1 will be selected, what is the input of D1? that is A or B. So the output will be the OR operation between these two registers A and B. Similarly, in case of when the select line will be 1 0, then D2 will be selected. That means XOR operation will be selected. Okay, so it will be A XOR B. So, by the logic operations, different functions can be implemented. So, the selective set operation set to 1 the bit of the register A when there are corresponding ones in register B. It does not affect the bit position that have zeros in the B. So, here if we do, suppose the content of A is 1010. Content of B is 1100. So what is the content of A after this? It will be 0 if we do the logical OR operation, okay? So it will be 0, then 1, then 1, then 1. This is the logical OR operation. So the two leftmost bits of B's are 1s. So the corresponding bits of A are set to 1. One of these two bits was already set and the other has been changed from 0 to 1. The two bits of A with corresponding zeros in B will be remain unchanged. So here there was 0 and the corresponding bit of 0 is 0. So that is why it remains unchanged. Here bit of B is 0, corresponding bit of A is 1. So that was unchanged. The output is 1. The selective complement operation complements bit in A where there are corresponding ones in B. Suppose if we do like this, the content of A was 1010. B is 1100. So A after this will be 0110. When? Because if we perform the exclusive OR operation between these two, then we will get this output. So here the two leftmost bits of B are ones. Okay, two leftmost bit of B are ones. So the corresponding bits of A are complemented. If it is 1, the output is 0. It was 0, the output is 1. And in the remaining case, what will be the example for that bit? Where in the two leftmost bits are 1, so the corresponding bits of A's are complemented. But in this case, no such issues occur. So here, these example again can serve as truth table from which one can deduce the selective complement operation is just an exclusive OR micro operation. Therefore, the exclusive OR micro operation can be used to selectively component the bits of the register. So, when we will use the set operation, in case of set operations, we will use the logical OR operation. Okay. In case of selective complement, it will be used the logical exclusive OR operation. Similarly, in case of selective clear, the operation clears to 0 the bits in A only, where there are corresponding ones in B. Okay. So, if the input for A is 1010 and for B the input is 1100. So, we will get the output as 0010. Okay. So, this will be A after this. Okay. So, what is the output? In this case, two leftmost bits of B are ones. So, the corresponding bits of A are cleared to 0. One such case, if we one can deduce that the Boolean operation performed on the individual bits is A-B complement. So the logical micro operation will be here A and B complement that will be stored in the register A. The mask operation is similar to the selective clear operation, except that the bits A are cleared only where there are corresponding zeros in B. The mask operation is an AND micro operation. So here, if the input is, suppose in the case of A, the A input was 1010. In case of B, the logical AND operation, the B output for input of B is 1100. So A after masking will be 1000. So the two rightmost bits of the A are cleared because the corresponding bits of B are zeros. Here, correspond two rightmost bits of A was 10 and after the operation the output was 00. So two rightmost bits are clear because of the corresponding bits of B are zeros. So the operation is performing here. The operation is basically the AND operation. So the mask operation is more convenient to use than the selective clear operation because most computers provide an AND instruction and few provide an instruction that executes the micro operation for selective clear. Okay, so these are different type of micro operations that can be performed with the help of the logic circuit design. So here we are basically using one multiplexer and four AND gate, four gates, one AND gate, one OR gate, one XOR gate and another NOT gate. So and implemented four micro operations are AND, OR, NOT and NAND. AND, OR, XOR and NOT. Okay. So the insert operation inserts a new value into a group of bits. Suppose we are doing like this. Suppose the insert operation inserts a new value into a group of bits. This is done by first masking of the bits and then ORing them with the required value. Okay, so suppose the data of A was 0, 1, 1, 0, 1, 0, 1. Okay, so suppose is and suppose after masking data is this. So here A after will be result 1, 0, 0, 0 and here 1, 0, 1, 0. So this is after masking. So in the insert the new value will be 0, 0, 0, 0, 1, 0, 1, 0 was A before, then 1, 0, 0, 1, 0, 1, 0, 1, 0. So the mask operation is an AND micro operation and the insert operation is an OR micro operation. So today we have studied different type of operation. One is set, another is clear, then AND micro operation for masking, for inserting the OR operation. Okay, so the clear operation compares the words in A and B and the produced on all zeros result if the two numbers are equal. This operation is achieved by the XOR microoperation. So if the content of A is 1010 and the content of B is 1010. So what will be the output? Output will be 0, 0, 0, 0, this 0, 0, 0, 1, 1, 0, 0, 1, 1. So here when A and B both are equal, that means the operation between these two is the XOR operation. This is operation A. So when A and B are equal, the two corresponding bits are either both 0 or both 1. In either case, the exclusive OR operation produces 0. The all zeros result in then check to determine if the two numbers were equal. So these are different type of logic microoperation. Okay. Thank you.